Thank you, Derek. And today we are looking at Caddie server and digital terrain modeling. The server environment in Caddie can import Y, X, and Z coordinates, WGS84, or from latitude and longitude GPS coordinates. Coordinates can be typed in, but are commonly imported from data files or Excel spreadsheets. Coordinates can originate from surveyors, the Surveyor General, aerial photography, or contour data. Once you've read in the data, you can automatically be orientated as per georeference data or external reference data such as GIS shape data. Surveyor's mode can then be set up according to the coordinate data. I shall now show you how to set up your survey mode. First of all, when you load the survey application, you'll get to survey mode setup. Once you pick on the command, a dialog will pop up. First of all, you can enable the survey mode. Then you'll type a Y and X value. Then choose the hemisphere you want to work in. In this case, I'm working in the southern hemisphere. You can then also pick the origin and physically pick the origin to set up the survey around that point over there. If you do not know if a survey mode is loaded on a drawing or is part of a drawing, you can go survey inquire, and that will tell you then a Y and X survey is active and you know that the survey mode is set up in your drawing. There's a couple of ways of setting up your survey mode. First of all, you can set it from a survey origin or read it from an origin. You can also calculate it from 2 points. Then, very important, you can also survey locate a drawing into another drawing, meaning that if you got another drawing with a survey mode set up, you can physically locate it relative to the coordinate setting that you've got on your survey mode. You can also then move coordinates accurately. You can do coordinate text, the Y and X positions. You can join text, which will give you the distance and angle, or you can just do the border of a site. Let me show you how that is done. I'll just zoom here to an unknown site, and I can physically, because my survey mode is set up, immediately go to coordinate text, tell the system I'd like to write it to my drawing or just display it on the dialog. Multiple lines, you can include the Z value and the number of decimals I would like. So I say OK. I choose a snap mode, and then I go to the corner, snap on a corner, and Caddie will write the Y and X for me. Join text works like this. It just needs 2 points. You can also say write it to the drawing, angle dimensions, degrees, minutes, seconds. The decimals is 1 on both sides. So I say OK, first point, second point, and Caddie will calculate between those 2 points. You can also just ask Caddie to do the border view automatically. What Caddie will then do, pick on the border, ask it to do the degrees, minutes, seconds, dimension to write it down, 0 decimals in this case, say OK, pick the site and the clockwise direction. It'll run around the site and will do that for you. You can then go and do point number inquiries. You can do spot heights. You can draw Y and X points. You can physically draw by Y and X, or you can draw in polar. This is an example. You pick the polar command. Caddie will ask you where's the start point. I can point to that point there. It'll ask me, okay, I'm going to draw in angles and distances. Let's use the default as is. So Caddie will draw that for you. Let's type another value in. 125. The delimiter is a dash. 00-09. And let's say this must be 65 meters. And we can say OK. And you can see Caddie will actually draw in that direction. Very important. When you want to do grid lines as these at the bottom here, your Y and X grid lines. Because you are set up in your survey mode already, you can physically just go to your grid lines, set up what you would like. The spacing is 100 meters, the decimals is 1, and I can even freehand just rectangle around it, and Caddie will go and calculate and draw the Y and X lines for you, and see it perfectly lines up to your current setting. So it knows where the origin is set at, and it can actually calculate it for you automatically. Moving on to survey 2. Over here, engineers doing roads can use transition curves. You can fit transition curves. You can do PIs. You can physically take all the points or a portion of the points in this drawing and then export them to a file. You can do interval symbols, meaning that you can put electrical boxes on the line. Interval text. You can do YXZ in. You can write coordinates to a file. You can physically do helmet transformations over here. You can do GPS in, meaning that you can load the GPS coordinates as I've spoken before, where you get a lat and a long. You can do a file import of them. It means GPS to grid coordinates. The configuration is Google Earth. The grid area is world. And what you then can do, you just load one lat and long coordinate, and you can actually project with GSAT, MRoads, or MSAT, or even hybrid drawings. Then you can also measure in that environment. But that is covered in the GIS webinar. Now we move on to the digital terrain modeling part of Caddie. You've now read in accurately the three-dimensional points from a file. First of all, as you've read in the points, you need to triangulate them. You go to the triangulation command. Caddie will prompt you. Do you want to do the scope? Do you want to do a rectangle? I'm going to use a rectangle for this. What layer should it be on? Let's say it's on DTM 1. What color should it be? And then you can say, okay, draw a box around it. And Caddie will run amongst the points, triangulate them. What it means, it does 3D polygons between the points. That's triangulation. After you've triangulated the points, you've now got a physical digital terrain model. You've now got a couple of options. The option to swap triangles means triangles like these long ones at the bottom here, you can swap them to make them far more accurately. You can now go and do contours. Pick the contours command. Caddie will prompt you. Show me what area you need contours for. So I'll rectangle that again, and Caddie will pop up with a dialog. It tells you your minimum contour height, your maximum contour height, your first major contour, the contour intervals, major contour intervals. Let's say the contour intervals is 2 and the major ones is 5. You can also set a different color to them. You can go about further down, you can label the contours. At that stage, I'm not going to do that. You can set layers for them, or you can just go and say, okay, and Caddie will run through and then calculate. And as you can see, it's calculated the contours for you automatically over there. Right. After you've done the contours, your DTM is actually a three-dimensional model. And if I turn it around like that, you can see it's a 3D DTM. What we can now do, just look from the top again, and I'll zoom in. Because you've got 3D data and accurate contours and also 3D polygons, Caddie will prompt you. Do you want to indicate or just use P for polyline? So I say P for polyline. I indicate the polyline. It'll run through, create the sections for you automatically, and then Caddie will actually ask you, right, would you like to write the section height? Yes or no? A very important one, vertical scale multiplier. People doing roads designs will use that. And if you say okay, it'll physically draw a section through your site, and you can just go and plonk it down. You can also do leveling of sites, minimum cut and fill. Let's do a minimum cut and fill. Pick that for you. It'll tell you. Use the shrinkage factor. It's basalt, so that's the factor for that. Number of accurate passes, 15. Retriangulate the outline from points or from a closed polyline. Let's use your closed polyline. We say okay. We can zoom up a bit more, indicate the polyline, and you can see as it happens there, Caddie will tell you the shrinkage factor, and it automatically retriangulated the digital terrain model for you. You can say yes, and it's done that for you. You can also use volume differences. So if I zoom out a bit, you can see I've got one digital terrain model over here. I've got another one to the top right there. You can say, give me volume differences. Caddie will then prompt you, indicate the polygon enclosing the vertices of the DTM. So I can say point there to point there, E for option end. And the second DTM, first point there, second point top right, E for option end. Caddie will go and do the calculations for you, and it'll tell you at the bottom here, the first DTM is larger by 9072. So you can do very accurate volume difference calculations as well. As you now have accurate DTM data, you can then do cross sections as well, like on a piece of road. If you have a look at the bottom here, there's a polyline. It's actually physically running in the center of the road over here. You can then do cross sections by going to the cross sections command. It'll prompt you a couple of questions. First of all, it'll say, show me the polyline. You show the polyline. It'll then go and ask you section intervals. Let's make it 20 meters apart. The section width, 18 meters wide. Vertical scale multiplier, let's leave that at 1. We include the reference level, which you type in over here. To the right hand side, you can write section heights. Then you can have a text style, maximum sections per row, and the vertical spacing, as well as the layering settings. So what you can do is say OK, and Caddie will run through it and then produce sections. Let's just zoom to those sections that it has printed. You can have a look over here. It actually numbers the section, give you the base level, give you the intersections as well. So you can do incremental cross sections through a road, through a ditch, or whatever was measured up. While having the polygons in your DTM, you get the angles of those polygons and actually display them for certain purpose. If you go to slope angles, you can go set up within a rectangle. You can indicate, you can say the minimum degrees, the maximum degrees will be red, between 10 and 20 will be yellow, 20 to 30 will be green, 30 to 40 will be in a bluish color. So if you say OK and you indicate with a rectangle, Caddie will run through the triangles, find out what the slope angles are, and it'll show you what those angles are. This can be used for depicting where you might be able to do some buildings, where you might be able to push a road through, or where you need to do cut and fill. If I tilt the model a bit, you'll see that it'll actually do it as a solid color as well. So you can then go and tilt your model, have a look at it, and see which angles and these triangles lie at, and where you can actually do building or where you can do some roads development. Thank you for watching this webinar with us. Please have a look at the GIS environment. There's also another mechanical webinar